Hi everyone, welcome. I'm really happy to be here with you under the Hamburg sun. It's a really amazing place here. I'm really proud to be here today. I'm going to be talking about, well, the title says most of it. It's my longest title ever. So it's about building a continuous delivery platform which had to be secure and flexible. You'll see what all that means. It's, of course, cloud native. We're at ContainerDays, and it's in the finance industry, hence all the security stuff. I'm Ádám Sándor. I work for Container Solutions, which is a consultancy company. So I'm going to talk about a project that I'm doing in the past year and still ongoing with my client called, or our client called Fiducia GAD. Who knows Fiducia GAD? They're a pretty big German company. So yeah, I see there are quite a few people who know the name. So Fiducia is a pretty old company. They've been around for decades building banking software. And they are really great at building large Java monolithic software. They're amazing at it. They have built software to build those Java monoliths because they're so huge and it's so hard to manage that they actually have like monolith assembly software. It's really cool stuff. See some people smiling at that, but remember that microservices are actually still pretty new. So building large monoliths was a completely reasonable thing and kind of still is in many cases. But it only gets you as far, right? That's what also the people at Fiducia GAD realized, that they can only release every few months because it's so hard to get all those modules, even with the cool management software, get them together, and you have one big bang release that just has to go right, otherwise you have a one big bang rollback. So it's all getting very scary then, and very error prone, and everybody's really stressed around release day. So they recognize there is all this cloud native going on and microservices and everything, so decided to jump straight on the cool new stuff and build new software using microservice architectures, package them as containers, and run them on Openshift. So that's where we came into the picture. They made a deal with Red Hat to build Openshift clusters. That's going to be their new internal cloud infrastructure. They decided not to go to a public cloud. Building banking software in Germany, public clouds are still a tricky place to be, plus they have data centers and everything, so it just made sense to build an internal cloud. And we were brought in as, at Container Solutions, we do kind of everything around cloud native, but in this project, we do not touch the clusters that's being set up by Red Hat and a team at Fiducia, but we have been tasked with building continuous delivery infrastructure on top of these Openshift clusters. So first, we landed actually inside a container at Fiducia GAD. Somehow, well, it's like really ironic. I forgot to take a picture, but we actually were put inside a container because there was no other office space. It was perfect with the Red Hat people, with the Fiducia people. We formed DevOps teams, everybody tasked with their own parts of this new platform. And when we started, there were no platforms running yet, no clusters running yet. So everything was very fresh, big discussions around how everything should be done. Should everything be completely new, or should the old ways still be somehow incorporated? And this is very tough to talk about these things when you're German and you want everything planned out exactly, but actually you don't have all the knowledge yet about how this will all work out. So yeah, lots of discussions. But what was happening was that the ideas about how to build out the clusters, there was multiple production clusters to be made because different regions, but it was very not clear even what kind of software will be running on those clusters. Do the legacy monoliths need to also run there, or is it just the new stuff that will be written from scratch? And also, like, there was so many questions. And in this environment, we had to start designing something of a CI/CD system. We knew that the CI/CD will be the glue over these different platforms, so it will be very essential that it does certain things right, but at the same time, we had to be sure we don't over-constrain teams because we just didn't know what they will, in the end, want to do. And it was also hard to define what exactly the first priorities are. But that came pretty soon, so because of the fact that at this point, there were no development teams involved yet in the building of this platform, the priority really shifted towards we have to make compliance and the security department happy. So whatever we build, they need to be happy. And that's perfectly reasonable in an environment like this. For me, what was scary was that while the ideas of DevOps and cloud native were not really embedded in the company yet, the old ideas of being scared of deploying anything and touching production, those were there. And as all the discussions with compliance came, I was worried whether that really rolls back DevOps and cloud native, like frequent deployments and continuous delivery and stuff. Fortunately, it didn't. We managed to come up with a solution that satisfied all these things, and we got down to work to implement this. One remark, we were really focused to bring DevOps and continuous delivery to this company. That was my take as a consultant, together with my colleagues from Container Solutions, that we really want to push this as far as possible. We knew that these guys cannot jump on like hourly deployments to production. That's not going to happen. But still, we wanted to push this as far as possible to have a continuous delivery workflow there. And to make that happen, we came up with the following solution. So first of all, just let's see how our continuous delivery workflow is working. And to see that, we need to go to deployments first. I think that's a very important point, is that deployments, automated deployments, are not really the key to continuous delivery, in my opinion. Many people treat automated deployments like they treat tests in Jenkins for CI, right? If you have automated tests, you don't yet have CI, but many people stop there. And if you have automated deployments, you don't yet have continuous delivery, but many people actually stop there. So, but first I need to explain the deployment part to be able to explain how the whole system comes together. So we start with a namespace on an Openshift cluster. Let's say this is the production namespace of my application. My application consists of 2 microservices, backend and frontend. Let's just make this all very simple because our focus is not to show a realistic application here. Actually, in the end, the development teams at Fiducia went all out and built like 8 microservices just straight out the door. Why not? I was quite surprised by that, but yeah, they're brave people. So we have a namespace. Our one environment, one stage in the CD pipeline is a namespace on an Openshift cluster. A production namespace will be located also on a production cluster, but one cluster can host multiple namespaces for the same team if they need that. There is a deployer process that will deploy to this environment, which is actually a pipeline inside a centralized Jenkins server that is 1 per cluster. There is 1 Jenkins per cluster. We decided to go conservative with the tooling a bit, so we decided to go with Jenkins and not try to push through something more new and fancy. We had our share of problems because of that, but we also had big wins in terms of people at the client actually understanding of what's happening without, like, a lot of stuff people didn't need to know because they knew how Jenkins pipelines worked already. And that really helped at many points in the project. So what this deployer pipeline does, checks out the code, does basically kubectl apply, and reports that it's done. Super simple. Of course, you can make much more interesting deployment processes, but that's, again, not the point here. So this is how this deployment looks like over many clusters. if you have a dev environment, a UAT, and a production environment, your dev and UAT live on the dev cluster, your production environment lives on the prod cluster. There will be 2 deployment Jenkinses running 3 deployment pipelines for you. Now, these deployment pipelines are hooked up to Git repos. Because the problem was, how can we give developers a flexible workflow where they can control their own pipeline, their own continuous delivery pipeline, but not have access to security-sensitive environments? That was our biggest question early in the project. Because we knew that without actually talking to developers, we cannot come up with a process, a one-size-fits-all process with just a few tweaks. We don't know what they will want, whether they will even want to do continuous delivery. So we needed something where, to make the security and compliance department happy, we had to make sure that we can prove that the production environment is not accessible by any developer or any tooling that the developers can directly, easily access credentials in. So all these deployment processes are hooked up to Git repos, and this is basically the Gitops pattern. Who knows what the Gitops pattern is here already? Okay, yeah, quite a few hands. It's not that new, but it's still not that utilized as useful it is. So what we did, every environment has a corresponding Git repo from where these deployment processes pull the YAML files, basically. It's the declarative YAML files that get pulled from the Git repos whenever something in there changes and deployment happens. Not a very complicated thing. The Git repo just contains all the YAML files that need to describe this environment, deployments, services, etc. Not the source code, but just all the YAMLs that describe the environment. Whenever that changes, deployment process kicks in, kubectl apply, done. Instead of kubectl, we have OC, which is the Openshift version of kubectl. Yeah, whoever doesn't know what Openshift is, just consider it, it's basically Kubernetes with extra stuff. I will not be explaining what the extra stuff is. Only one remark about Openshift, I was really happy with all that extra stuff they did. It's a really cool product. If you want to have like a really enterprise secure Kubernetes, Openshift is a very viable option. I really liked working with it. And it has a pretty UI, actually such a good UI that I like to use it many times instead of using the command line. And I do like using the command line. So that's a pretty good work from Red Hat there. So to the continuous delivery part. This is the pipeline of a team that runs in their own Jenkins. Every team gets their own Jenkins. With that, we avoid all the problems with Jenkins stability and scalability. The team can customize this pipeline. We have a recommended continuous delivery pipeline for them, but they can customize it. And you can see what happens here. This pipeline is for a single microservice. So we do continuous delivery per single microservice, no bundling of many microservices together. If some team wants to do that, they can do that, but the default process they get is per microservice continuous delivery. It's very important because people so many times end up building distributed monoliths. They start building microservices, but oh, it's very hard to deploy them separately, so we just go bundle them into one huge Helm chart, shove them at the cluster, and again, you have big bang deployments to production. The same you had with the monolithic software. Maybe your code is slightly better organized, but otherwise, you end up easily with the same deployment problems. So this pipeline is only for a single microservice of that team, while that environment follows for all the microservices that you've seen before. So it checks out, runs tests, compiles stuff, builds a Docker image, and then creates a pull request against that Git repo, which is describing the environment. So the development deployment from the team's perspective is not running kubectl apply. It's actually writing into that Git repo from where this process is pulling from. So there, on the left side, the checkout to the dev environment is pulling from the same repo that this process is creating a pull request against. And because it's the dev environment, it's going to automatically merge the pull request. So Gitops is not beautiful because Git is made for rather for editing files by a user. And if you want to have Gitops deployments, but you also want to automatically deploy from a pipeline, you will end up writing into a Git repo from Jenkins. That has its own problems, but actually it's not that bad. You need to put a few retries in there, and it's fine. And then actually this pipeline runs further, because what we wanted to do is one long continuous delivery pipeline that takes code from build to production all the way. It's very important, because if this pipeline is segregated into a whole completely different production deployment pipeline, then what this ends up with usually is that the teams don't even end up seeing what their production deployments, when are they happening. As was exactly the setup Fiducia had in their previous prototype running on Docker Swarm, where every sensitive environment deployment was actually running in a Jenkins that only the ops team had access to. So DevOps was out the door immediately, because development teams basically built their Docker image and then just forgot about it and waited that someday someone will push the right button and will deploy it. We wanted to have an end-to-end pipeline. So here is how it looks like, the part of the dev deployment and the production deployment. And you can see the difference there. This is where security happens and compliance. So to the production deployment, the team's Jenkins does not have access to merge the pull request. Only an authorized person can merge the pull request. And with that, we practically have the problem solved of this segregation of developers from the production environment, but in a way where, from their perspective, is still their Jenkins basically doing something with a Git repo and then waiting for deployment to happen. That in between, there has to be some approval process happening. They don't need to care about it. And each environment is deployed in exactly the same way. Just the only difference is this tiny tweak, whether or not somebody authorized has to merge the pull request. So it's a very smooth flow. It's as smooth as you get to continuous delivery in a security and compliance conscious environment. And you can tweak this, right? You don't need to change architecture. If you want more or less continuous delivery, you can put on an approval on every single environment if you say you don't trust anyone in the development team, or you can remove that approval step from the production environment if you do want to trust developers to deploy to production. And this is the whole big, beautiful picture that I was told to need to slice up into smaller pieces because nobody will see it, and I guess that's pretty true. But up there is the pipeline for a single microservice. So one team will have multiple of those pipelines. And down there are the environments to which these deployments go. So one of those Gitops repos in the middle, they will host all the microservices that run on that environment. So every microservice pipeline will write into a directory inside those Git repos. And with this, we have a nice continuous delivery pipeline. Here is an example of the beautiful Jenkins interface. That's why Rudder was showing this. How does it look like in Jenkins? This is a pipeline with two stages, with ETU and ITU, which are dev and UAT, kind of, some German abbreviations. Not sure what they mean. I never managed to remember them. So you can see there are failed pipelines and some pipeline that goes all the way through to UAT. Or no, actually the last one failed after the dev environment. So the idea is that this pipeline will go all the way to production. One thing, how we were thinking about this, one important idea was that we did not think development teams, that all development teams, there were tens of development teams that needed this stuff. So we knew that they will have different ideas about whether or not they want to do continuous delivery or not. So one interesting point here is that we implemented something called the monolithic stage promotion. Let's say a team wants to deploy to production as a distributed monolith, because actually mastering continuous delivery with microservices is not easy. So we didn't expect every team to just be able to do that, especially with already building maybe 8 microservices. But when you get into this discussion, what comes next is, oh, we need to build bundles now. We need to have version matrices, which version of which microservice works with which other version of another microservice, right? You get these discussions, and quickly you go down into building stuff for a distributed monolith architecture. And we wanted to prevent that while still helping developers who are struggling and who would not be comfortable with deploying single services to production. So what we gave them is a simple feature that's very easy to implement with Gitops. If you manage to assemble a working thing on UAT, let's say on UAT, you are deploying microservices individually, and at some point, you reach the state when it actually all works together. That's when you can push the monolithic stage promotion button, and the whole thing just gets moved into production as one whole. So with this, you get the benefit of kind of this safe deployment that, okay, I'm deploying something, I know that the whole thing works together, but you don't go down the route of building complex management around like which version of a microservice works with which other version. And with Gitops, implementing this stuff is actually very simple. You just copy over the UAT Git repo into the production Git repo, and you're done. So at this point, we did a bit of evaluation. We already had 1, then 2, and then 3 development teams working with this stuff. So we got some feedback. We were setting this all up manually for them. One Jenkins, here you go, a Jenkins, Git repos, deployment pipeline, all that stuff we set up manually. Problem was they were still not doing any production deployments, so the feedback was kind of limited. But to their dev environment, they were deploying microservices independently and immediately after merging to master. So that's a continuous delivery workflow for me, even if it doesn't go further than dev. Yes, they were struggling with reaching a working state on their environments, so that was expected. It was all new to many people, and yeah, that's just need to learn. And we were doing manual provisioning, which is, of course, not sustainable. But the feedback was good. They liked it. It was working. People actually, yeah, the developers were quite happy with the setup. And the security people were happy that all this segregation of the delivery pipeline from the deployment pipeline through the Git repo, this delivers what's needed there. So then our next thing was automating the provisioning of this system. System consists of, like, right, there is a Jenkins for the team, namespaces for the team, Git repos for each namespace, and deployment pipelines for each namespace. That's quite a lot of things that need to be created. And we were in some trouble at this point because we didn't start early enough on the automation, because we first want to get the feedback, is this even good? But management already decided that, oh, look, some teams are deploying, so CI/CD is done, right? Let's go. There is 20 more teams. Get them working. So we pushed a bit back, onboarded some teams manually, and in the meanwhile got really down to building the automation. And that's where we ran into a problem. We were provisioning very non-standard things here that Terraform, for example, doesn't support. None of it, basically, what we needed to do. Even the Kubernetes plugin for Terraform doesn't support Openshift objects. So even that stuff that we nearly had, like, but then no, because we actually needed some Openshift specific objects. So we started on 2 tracks. One, trying to build Terraform plugins for everything that we do. The other was building it just in Java. So with Java, we picked that because it's a general purpose programming language. We could have picked anything else. But Java has a good Kubernetes client library, and that was what most people knew on the team. So we were safe there. So what we built, in the end, we failed miserably with building Terraform plugins. It was just too hard, and even what kind of worked, the result was not great. We built this provisioning jar that is a binary. It's written with our custom code using a library for accessing Jenkins, a library for accessing Kubernetes, library for, like, okay, REST calls for accessing Bitbucket. And it gets not an EM YAML, but a team YAML as input with just the team's name and a list of environments, which is also a bit screwed there, but it's a YAML file with a name for the team and a list of environments. Basically, that's all we need to know about a team plus action admin user. And the nice thing about building this in Java instead of Terraform is that you can do abstractions. So actually, our input is seriously just this tiny YAML file, and we can create the world based on that, because we can, in a programming language, you can do whatever. Our Terraform input, even before it would like fail, it was already getting huge because you have to work with much lower level objects and work around Terraform things. So we started provisioning teams with using this command, and it worked fine. It was work to do it, but it was fine. Then our next challenge was to build self-service. Self-service was always on our radar as a nice-to-have feature. Once things started really ramping up with teams going beyond like 50, 60, 70 teams, self-service, we realized, is not a nice-to-have feature. It's absolutely essential to do, but because the request we got is not just creating new teams, but also now add the new environment, etc. And we were swamped. Even with that automation tool, it was too much. And we decided to build self-service using the operator pattern. We could have hooked up that, no, I'm not going to show you that yet. We could have hooked up that provisioning tool we built to a Git repo and build like this classic automation where Jenkins runs a pipeline based on some files, these YAML files in the Git repo, and the provisioning runs when the files change. But that's not flexible enough. There is no feedback loop. It's like a very one-off process. It's hard to handle security. Who can access that Git repo then, and who will edit the YAML files in there? Because this stuff is actually controlling creation and deletion of production environments. So we decided that operators are a really hot thing now, and I'm really enthusiastic about the pattern. The operator pattern is basically the same pattern what Kubernetes uses internally to manage objects. It's a continuous control loop. Let's say when you create a deployment in Kubernetes, there is a control loop that will see the deployment, spin up pods, actually replica sets, but let's say this spins up pods for the deployment and constantly monitors, are there exactly as many pods as the deployment needs? If the number of pods change because something fails, or the number of pods change because a deployment object is changed, then the deployment controller will reconcile the state and will always make sure you have the right state on Kubernetes. And this is the principle what we wanted to make, but with development teams. So what we will do with the operator pattern is you build your own software and the custom resource definition that you put into the API server. So the Kubernetes API server supports putting custom resources in there. So instead of deployment, you will have your own resource. And that, in our case, is a CI/CD team. So our team YAML, that was a YAML file on my disk before, becomes the CI/CD team resource inside Openshift's API. And we named the system Charon. At this point, we realized, like, let's give it a name. And Charon, as the servant of the gods who carries people to the afterlife, sounded like a good idea for a CI/CD system. The Charon operator monitors what's inside the OpenShift API on our management cluster and creates all the things that previously the provisioning application was creating. We are still in the middle of implementing this, but things are looking good. And we put an API in front of the OpenShift API that our users will actually use. And that API will write a new team or update a team inside the OpenShift API, and the operator keeps running the loop and keeps making sure that the teams that are defined in the OpenShift API have all their resources provisioned correctly in the real world. In the real world. It's a bit confusing with the screen being here the other way around. Yes. So that's still an ongoing process, and actually, it's even a more complex setup than this, because we want to create operators for each type of resource that we are creating, and then a master operator that will be breaking down a team into all these sub-resources. So we're really going far with this, but I'm quite confident that this is going to be a good thing in the end. So let's recap I have a clicker. Let's recap the design decisions we made in this project. First of all, we pushed per microservice continuous delivery as the default process to teams. They can do whatever the hell they want. They can even replace their Jenkins with something else if they really want to. But our default process that we give them is per microservice, really hardcore continuous delivery. Change master, and the process kicks in, and the process expects that any artifact that's built from a change of master might go all the way to production. Might not, but there is no special release step like, okay, we spent the last month testing this artifact, now we release it. No, the expectation is that things go fast, one after the other, the changes. We segregated the deployment pipeline from the delivery pipeline. The delivery pipeline is the workflow pipeline that is managing the continuous delivery, while the deployment pipeline is just deployment automation. And we segregated these through the Gitops pattern by the delivery pipeline writing to a Git repo and the deployment pipeline picking that up. Also, I didn't mention, but this way, of course, on every Git repo, we can control exactly who can change the environment. All environment changes need to go through the Git repo. We built provisioning automation using Java, which is not a thing many people think of, but actually it worked out pretty good for us. As having many Java developers on the team, this went like really smoothly. You need to write more stuff than if you would with Terraform, but it's fine. In the end, the flexibility you get out of it can be worth it, depending on what you're creating. Of course, if you're creating things that are out of the box supported by Terraform, then yeah, then that's probably going to be much faster. By the way, there are also operators that run Terraform, so that's also one way to do operators. Yeah, and then we use the operator pattern to create a truly, or using the operator pattern to create a truly self-managed platform. That will be just an API for the teams, that everything happening behind the scenes. Yeah, and the lesson we learned, continuous delivery and DevOps is not exclusive from compliance and security. So the two can work nicely together. Maybe it will not end up with like 10 deployments a day, but you can get pretty close, and you can get closer than many people think to a true continuous delivery workflow. Gitops is not perfect because Git is not meant to be written by software, by external software, but more by people editing files in it. But it's good enough. We did not have big problems with it, and it's very cheap. All the things in this scenario that Git takes care of for you, versioning, audit logs, security, like user management, and an approval process, all this stuff would be very hard to build. I already talked about Java or other general purpose programming language being a good tool for building provisioning automation, and that self-service is an essential feature when you're building for a large number of teams. Thank you very much for listening. You can find me on Twitter under Ádám Sándor with a 0 there. I'm very happy if you tweet at me. Also things that you think we did wrong. I'm really, really interested in hearing what you all think about all this stuff. Also, you can reach out to me on my email. And we actually started creating an operator SDK. Like there is an operator SDK for Go already. But because we're writing operators in Java, we need a base library for it, so we started creating an open source project for that. So anybody interested, go check it out. It actually works. It's a very early stage, just few commits, but it does work. There are some samples and everything, and if you would like to contribute, we're very happy to hear from you. Thank you.